Hello, students, and welcome to the notes on using marginal frequency distributions. These notes, actually, you'll learn how to utilize a two-way table and construct a relative frequency distribution and create a conditional relative uh, frequency distribution. So let's get into it. So a two-way table is just a format that's used to organize data. And we have an example of this, how to create two-way table and utilize it. So each student in a random sample of seniors at a local high school participated in a survey. These students were asked to indicate their gender and their eye color. The following table summarizes the results of the survey. So the data is just organized based on how many males have certain eye color, how many females have certain eye color, and the total for each of those two categories. So in the survey, we could see that there were 200 total students that were surveyed. 110 were male, 90 were female. Out of those 200 that surveyed, 90 had brown eyes, 80 had blue eyes, and 30 had total 20 of green eyes. And then out of those 200, 50 were males with brown eyes, 10 were females with green eyes. So that's how you read the data in that particular table. So based on that, we could answer the questions that we have here. Question A, what is the probability that a student from the survey had brown eyes? So all we're interested in is in total brown eyes. So we don't care about the gender of the people with brown eyes, just how many have brown eyes. That'll be 90 out of 200 total students. That simplifies to 9 over 20. Oops, my pen's not working too well. Which is 45%, or 45% as a proportion is 0.45. In B, what is the probability that student from the survey was a female? So how many total females did we have? 90 out of 200 total students. Once again, that came out to be 45%, or as a proportion, 0.45. More specific questions can be asked, such as, what is the probability that a student from the survey was a male with green eyes? So we need to look at males who have green eyes. That'll be 20. Out of the total of 200 students, so that'll be reduced to 1/10 or 10%, which as a proportion is 0.10. And with D, what is the probability that the selected student is a male given that has blue eyes? So we're given that the student has blue eyes, so we're looking at that column. So student has blue eyes. What percent is it that it's going to be male, or probability of a male? So that'll be 40 out of all the people with blue eyes. That'll be 80. So given that student has blue eyes, it's a 50% chance that the student will be randomly will be male, or as a proportion 0.50. All right, so when we have just simply counts, that is how many people meet the certain qualifications, qualities that we're looking for, then we have a frequency distribution. If we want to change this data into percentages, then we're going to have what's called a relative frequency distribution. And the way you do that is you just convert your raw data, all the counts, into percentages. So, for example, let's look at right here. We got 50 male students with brown eyes. What percentage of the overall survey takers is that? Well, that'll be 50 over 200, and that equals 25%. How many were females with brown eyes? That'll be 40 over 200, and that comes out to be 20%. How many were total students had? What percentage of the total students had brown eyes? That would be 90 over 200, or 45%, which happens to be the sum of those two numbers. And you do the same thing with the blue eyes for males and females, same thing for the green eyes for males and females, etc. And when you do that, you get 20% here. You'll get 20% here. When you take 80 divided by 200, you get 40%. So that will go there. Green eyes, you'll go 20 divided by 200. That gives you 10%. 10 divided by 200 is 5%. 30 divided by 200 is 15%, which happens to be, once again, the sum of those two numbers there. Find the total percentage of students that were, or survey takers that were male, 110 out of 255%, which once again, if I add up those three percentages, I get 55%. And then percentage of females is 90 over 200, which is 45%. And the last thing is the total, the grand total of the students surveyed. That would be 100%. And that's how you figure out the relative frequency distribution. All right, so my data disappeared, but you should have it on your paper. If not, rewind the video a little bit so you could get it again. I'm just going to continue on with the 25 to 50 range for cashier lane. That would be 151 over 605. And if I want to figure out over 50, that'll be 224 over 605. And this will be 100%, 605 over 605. So we got 100% of all the data in the cashier lane. So let's fill up the 25 to 50 range. 151 divided by 605 is 0.2495867, whatever. Thing is, when I multiply this by 100, then I'm going to have 24.95867 as a percent. That becomes, I need to truncate, not truncate, I need to round it after the 5. Since the number after the 5 is 8, and that's 5 or more, I round up. I'm going to round up the hundredths value. So 24.96. Likewise, if I go 224 divided by 605, and let me do that again. I didn't enter it correctly in my calculator. 37.02. And our original, the less than 25 range was 38.12. Oh, 30.02, my bad. I lost that data. So, and once again, if we add up these three numbers, we get 100%. Alrighty, on to the final part. So let me just rewrite and fill it up so we have clean numbers. 26, 15, 6, 14, and 33. All right, part B. What is the probability that students study physics? There are 33 total students out of 80. That gives us 33 divided by 80 comes out to be 0.4125, which is equal to 41.25%. Part C, what is the probability that a student is a male and does not study biology? So is a male and does not study biology. That means we got 6 males doing chemistry, 19 doing physics, that's total 25 out of 80 students. 25 divided by 80 gives us 31.25%. Part D, what is the probability that the student is a female and studies chemistry? So we're looking at female, studies chemistry. It's 15 out of the 80 students. 18.75%. And then finally, what is probability that the student is not a female, which means the student is a male? So that's 33 out of 80, 41.25%. All right, now that you're done with this, when you go in Mathia, work through all of the workspaces in the using marginal frequency distribution unit, which is in the unit titled probability. Good luck. Take care.